So now for 1.1, let's talk about domain and range of these functions. So the domain is the set of all possible x values of a function. So the graph, how far left, how far right does it go? The range is a set of all possible y values. Again, y goes up and down, so how far down to how far up it goes. And we write our domain and ranges in function notation or interval notation, okay? So down here, it gave us our parent functions. Let me erase some of this, sorry. It's from previous notes, there we go. And it gives us the domain is all real numbers for all four of these. That means these graphs, they're going forever left and they're going forever right. So in interval notation or function notation, we actually write that as negative infinity to infinity. It goes forever to the left, so that's negative infinity, and it goes forever to the right, and that's positive infinity. And infinities always get parentheses, so all of these domains are negative infinity to infinity. Okay, the range is where things get a little different. Okay, so the range of a constant, well, it's all the possible y values, and if this constant, if this parent function is 1, and it's a constant, it is y is always 1, so y equals 1, which we would write that as a bracket 1. The brackets mean it exactly equals that number. The parentheses means it leads right up to that number, but since infinity goes on forever, that's why we use parentheses. There's no end to it. Okay, straight lines or linear functions, they go down forever and they go up forever. So down is negative infinity, up is positive infinity. Absolute value, that parent function, it starts at 0, 0. That's where that bottom of the V is. That's as low as that graph goes. So it's going to actually equals 0 when y is 0, but it's going to go up forever, so that is infinity. So it gets a bracket before the 0 because it actually equals and stops at 0, and it gets parentheses after the infinity. Okay, so that means its bottom point is 0, but the arrows are going up forever. Okay, and quadratic is the same way. It's when y is greater than or equal to 0. So the bottom, the lowest it goes is 0, and then it goes up forever, okay? So that's how we're going to write our domains and ranges. So when we go to problems number 10, 11, 12, and 13 in our notes, this says identify the function family and describe the domain and range. You can graph it on your calculator to determine if you're correct. We know number 10, this is basically in the form y equals mx plus b, right? So this is linear. So I know my graph is, I'm not graphing it exactly, but I know linear graphs look like that. So I know my domain, and I'm not going to write it completely out, is going to go left forever and right forever. So it's all real numbers, negative infinity to infinity. And the range goes down forever and up forever, so it is all real numbers, negative infinity to infinity. Okay, number 11. There's no x, it's h of x, which means the function equals negative 9. So there's no x involved, so I know this is a constant, okay? But it still goes left and right forever. Remember, constants are horizontal, so it's going to be negative infinity to infinity. And its range is just going to be negative 9. Doesn't equal any other numbers. The y's are never going to, like even negative 8.9, that is not a value. It's only negative 9. All right, number 12 is an absolute value graph. And my slope is positive, so I know it's aimed up, like the parent function is aimed up. Okay, and this right here tells me it went up 1. So instead of being at 0, 0, I know this is at 0.01, okay? So when I'm writing, it still goes left to a negative infinity and right to infinity. But its bottom of the graph, which is this point right here, okay, it's going to be at y being 1, okay, because it was up 1 from 0, 0. So I know the range, the bottom, the lowest it goes is 1, and it's going to positive infinity. Now, If this was negative, had a negative symbol out front here, you would have changed that. It would go down forever because a negative absolute value is aimed down. So it goes down forever, so it's negative infinity. And its top would be that top y value of the point. All right, so number 13. Now this is, again, its absolute value, and it's positive out front, so I know it's going to be aimed up. This time there's nothing grouped in here with x, so it's not moving left or right. There's nothing outside here tacked onto the end, a plus or minus a number, so it's not moving up or down. So this one actually goes through point 0, 0. Okay. It didn't have any translations involved, but its domain, all real numbers, negative infinity to infinity, and its range, the lowest it will go is 0, the highest it will go is forever, so positive infinity. All right, so go on to the practice and do number 39, 40, 41, and 42.